Hi everyone. So the goal of this is to look at the more complicated gravity equation that you might have seen at the end of your guided notes. It is a very useful equation. It applies to anything in our universe. I might make this like a should do or aspire to, but I hope you try to take on this challenge. And I wanted to give you an example of what this math problem would look like. Like how do you use this equation? So I came up with this problem and we'll kind of go over it together. So the question is, what is the force of gravity between a 65 kilogram person and the Earth? And we have some numbers about the Earth. We have the Earth's mass, we have the Earth's radius, we have the gravitational constant. All right, so we're going to write out a few things really quickly. And if you've seen other videos from me, especially when it comes to math problems, you might have seen I'm going to use this acronym of GUESS. All right, again, that stands for given, unknown, equation, substitute, solve. So I'm going to think about what am I given in this problem? And I'm given a lot of numbers. So let me write out some of these things. So I know that we have a mass of a person, let's call that M1, is 65. I have the mass of the Earth, we'll call that M2, is this really big number, 5.97 times 10 to the 24th. All right, and then I have a radius, which is 6.38 times 10 to the 6th meters. And then I have this gravitational constant G is 6.67 times 10 to the negative 11. All right, so that is all that I was given in the problem. And then the question is asking, what is the force of gravity? That's my unknown. So I have my given. I have four values given to me. My unknown is the force of gravity. And now I need to figure out what equation do I use to find this value. So there's an equation that I gave you in the guided notes that looked like this. The force of gravity is equal to the constant G times mass 1 times mass 2, all of that divided by the radius squared. So that's the equation that we want to use. So I have my given, my unknown, my equation, and now I'm going to start substituting my numbers in. So substitution, just going to plug in some of the numbers that I was given. So G, 6.67 times 10 to the negative 11. You know what? I'm just going to move this over here so we have more room on the paper. So we'll do FG is equal to, let's see, we have 6.67 times 10 to the negative 11th times the mass, 65, and then my other mass, which was some really big number. All right, and then all of that divided by r squared. So my radius is 6.38 times 10 to the 6th, but then I have to square that. So that's going to be squared. Okay, so it's pretty busy here, but we're going to go over the math. And so you might see some of the exponents here that might be a little bit confusing. But we talked a little bit about scientific notation. So we have a few numbers here in scientific notation, and there's some basic rules about multiplying and dividing numbers in scientific notation. And the rule is you can multiply the numbers in the front, and then you want to add the exponents when you are multiplying. All right, so I might multiply these two big numbers together first, just to simplify it, and then we'll handle the 65 next. So I'm going to do 6.67, and you can even do the whole thing in your calculator. 6.67 to the negative 11th. All right, so we can see 6.67 times 10 to the negative 11th. All right, and then I'm going to multiply that by my next number. What's my number for Earth? It is 5.97 times 10 to the 24th. All right, so I get 3.98 times 10 to the 14th power. So I'm going to rewrite some of this. I've really only simplified one number here, but I have 3.98 times 10 to the 14th. All right, I still need to multiply that by 65, and I still need to divide it by my radius. Okay, so let's do the next easiest thing would be multiplying it by the 65. So let me take my number here, and I'm going to do times 65. All right, so now we have a new number here. So we have the force of gravity is equal to 2.5, let's just round that, 2.59 times 10 to the 16th power. Again, still dividing by this radius. I haven't gotten to that yet. Okay. All right, so my numerator looks pretty good. Let me handle this situation real quick. So I have my radius, but I need to square it. So I'm going to go 6.38, and my exponent is 6. Okay. Let's see if I can do this. What happens if I do this? That looks good. Okay. So when I square it, I get 4.07 times 10 to the 13th. So I'm going to rewrite this. 2.59 times 10 to the 16th divided by 4.07 times 10 to the 13th. Okay, and now I just have one more step to do here. So I'm going to take my 2.59 times 10 to the 16th, and I'm going to divide that by 4.07 times 10 to the 13th. And I get 636 newtons. Okay, so that tells me that a person that a person that has a mass of 65 kilograms, this is their force of gravity, 636. All right, so that is really the force of gravity between the Earth and the person. All right, and here's a little fun fact for you. This number, because we're dealing with objects on Earth, and I said that objects on Earth experience an acceleration of negative 9.8, I bet this is going to be very close to the mass of the person times negative 9.8. All right, so, and I'm really just showing this to show that this equation applies to everything in our universe, but it's not like the force of gravity that we're using here is any different from the force of gravity when we talk about the force of gravity on Earth, right? If I was going to do this number here, and it might show up as a negative instead, but if I do 65 times negative 9.8, I get 637. So 637. All right, the only reason why these numbers are off by 1 is because probably of some rounding error in some of these big numbers. All right, but that's pretty much it. So I wanted to show you how to use this equation. And if you wanted to pay attention to the video and maybe rewatch it, check exactly what numbers I was hitting on the calculator to handle the exponents. But the calculator does a pretty good job of handling these exponents, and I can show you in class if you need to. But you can slowly simplify this until you get your force of gravity, the force of gravity between the person and Earth. All right. So hopefully this was useful. Again, this is kind of like a challenge, so I might make this like a should do or an aspire to. But I think this is a really useful equation in terms of the general law of gravity in our universe. All right, that's it. Good luck.